The Clayco Advanced Construction and Material Laboratory is an expansion of the Butler-Carleton Civil Engineering Hall. This is going to give us unmatched capabilities at Missouri S&T to design, build, and think about a future that doesn't exist yet. Our infrastructure materials capabilities will be unmatched across the Midwest and really across the country. It'll give us a capability to think about how we're going to design our future, and our students, our faculty, and our staff will go out and they'll change the world with the work they're going to do here. Welcome. I'm glad you were able to join us today for our tour of the afternoon. We've been known at Missouri S&T for leading the way for a lot of things and a lot of time, and civil engineering is certainly one of them. We've got one of the finest labs in the country when it comes to infrastructure testing and structural analysis, and we're moving into the future with the Clayco Advanced Construction and Materials Laboratory, and we're just going to give you a little bit of a peek today, unscripted, unrehearsed, but I'm here joined with Dr. Kamal Kayat, who's leading a lot of the efforts and getting us going on this. And we're going to walk you through some of our new facilities and what they're going to be.
Thank you, Joe. We're very excited to showcase this new ACML lab that is still under construction. Started about a year ago, and we are hoping to have it delivered by the contractor in the middle of July. And then to us as a department, as a center, by the middle of August. This lab has a total square area of about 14,800 square feet. It consists of a first floor over here with a high bay, plus a mezzanine on the second floor that will take you to visit. Where we are right now is a connection with the existing building, the existing materials lab. And in this space over here, we'll have some very exciting capability. First of all, we'll be moving here from another building, our biggest press on campus, which is a 1 million pound testing machine that allows us to do testing static and dynamic. We'll have a frame over here for dynamic testing, including fatigue. And we'll have also a setup for a 6-degree freedom articulated 3D printer for concrete structures.
So we've got a proposal in the National Science Foundation to have a campus-wide facility housed right here that would give us the capability to print 3D materials with concrete, reinforced concrete, as well as composite materials. And NSF is reviewing that proposal right now. So hopefully by the time we're open, we'll have a little bit more information on will we have that capability underneath our roof. So we've got a great facility and a roof above us now, and we're looking to build this out to be the best instrumented lab in the Midwest for sure, and maybe the nation.
It's important to know that this is an extension of the civil engineering building, but this is part of a research center. For example, for this 3D printing, we have faculty members and research teams from robotics, from computer science, from mechanical engineering, as well as structural engineering and materials. So this is really a multidisciplinary research lab.
And it really is. So it's connected to our building, but this is going to bring in researchers everywhere from fundamental chemistry to material science across the board and give them a facility to work together. It's something our campus has never had before. So now we're on the western side. Electrical engineering is just off to my left. But we were thrilled that we worked with the architects really closely, Christner out of St. Louis, and we were able to bring in a lot of natural daylighting. And daylighting really gives this space a good natural feel. We're going to have a lot of high-end research going on in here day and night. And it's also going to be very, very welcoming. As you come in from campus from the north, this is going to be the first thing you see at campus will be this facility. And Kamal's going to talk about some of the facilities that are going to be brought into here that we've already got on campus.
All right, so the Advanced Construction and Materials Lab has two phases. This is phase 2, where we have shelter over about $2.8 million of equipment that we acquired in 2011, which was inaugurated in 2012. And it consists of 35 state-of-the-art equipment that were obtained through a grant from US DOT. And one of the equipment that came from Germany is a concrete batching plant. This is a 1 cubic yard concrete batching plant, fully automated. Right now it sits outside campus. The university had to rent some space for us for the last 8 years to operate that batching plant. And we're very, very happy that it will be sitting over here in tandem with its small sister that we call the small orange versus the big orange. And the small orange is 1 cubic yard. And they'll be sitting here in tandem, and they will have many siluses. So we'll be able to do any type of cement-based materials, really concrete a la carte, where we can dream very big and produce the next generation of construction materials for rehabilitation and construction of our infrastructure. We are standing here in the control room for the concrete batching plant. We have two concrete batching plants, one cubic yard, and the other one is 1/3 of a cubic yard. Everything is automated. We have some dispensing equipment for admixtures, conveyor belts for aggregate materials, and this is where it's all happening.
And this is one of the unique facilities that the ACML is going to hold overall. This is going to be one of our environmental chambers, so the entire room will be turned into an extreme environment. We'll be able to swing temperatures from -40 up to 60, and at a variety of humidities and with different aspects like salt water and such, that'll really test the materials that we're going to develop here and see how they're going to do in those extreme environments. And as we look at engineering beyond the boundaries of our country especially, we're going to need this type of facility. The Army Research Labs are very interested in this as far as a capacity where they can test some things that we're doing in collaboration. But this is just one of the facilities. Let's go see some more.
The first floor of the ACML, we mainly work on the civil engineering aspects of construction materials. In this case, we're talking about mainly cement-based materials. So we have the mixing room, the queuing room, the extreme environments rooms, and over here you have something very important for civil engineer, and this is a shrinkage and creep room. So we're looking at the viscoelastic properties of construction materials. This room over here will be holding a lot of very high strength creep cells going at least 10,000, 12,000 PSI active stress. And then it will have also some specimens subjected to 40%, 50% humidity, about 20 degrees Celsius plus or minus, to evaluate the drying shrinkage, autogenous shrinkage, restrained shrinkage that cause a lot of cracking in concrete structures. And this is our moist curing room. So concrete has to be moist cured for a certain period of time to sustain cement hydration and reduce porosity and improve mechanical properties and durability. And this room here will have sprinklers, basically to keep the specimens that we put over here, either small specimens or large scale test specimens, at 100% humidity at constant temperature, about 23 degrees Celsius. It's important also to point out that at Missouri S&T, we have 4 signature areas, what we call the strategic investments, and one of them is called Advanced Materials for Sustainable Infrastructure. That allowed us to hire 4 faculty members. Some of them are here in our department, Civil Architecture and Environmental, others in Material Science, and others also are in Chemical Engineering. And here we have a room that is dedicated for rheology. Now we have faculty and students in our department and outside very interested in the science of rheology, and that is related to affecting the workability of cement-based materials. So here we'll be moving some rheometers, again from the CIS, that are really state-of-the-art, and I think as a university, we are the most equipped university in North America in the field of rheology.
And now, welcome to the second floor. The mezzanine up here houses the project room, which we're in right now, where the students, staff, faculty, and collaborators from other places can come together and work on the projects that we're going to carry out here as the research. And the second floor really takes advantage of natural lighting again. We were able to work with the architects to bring in a lot of it. So there's no lights on at all right now, and it's actually a cloudy day. So we're going to have a lot of facilities up here that are very nice to work in, including the calorimetry room.
So calorimetry room is a very important room for our research. It allows us to follow what happens to the cement-based materials in the first 24 hours or 48 hours of the life. We'll have here some very unique equipment that look at the heat signature that is generated when cement hydrates. It will allow us to evaluate the suitability of various materials, including recycled materials, waste materials, chemical admixtures, and how they interact with the cement-based materials, and develop the microstructure in the first 1 or 2 days of the life of the material. Concrete structures often are deteriorated due to issues with durability, and therefore the use of high-performance construction materials for construction and rehabilitation is very important to extend the service life. For example, at Missouri S&T, our researchers have been working on new construction materials and reinforcement, composite reinforcement that allow us to design and build bridges that have service lives over 125 years, and design concretes that have 3 to 4 times the service life of conventional infrastructure materials. This room here is dedicated for this type of service life prediction and durability testing, whether it's corrosion of reinforcement in marine environments or behavior of concrete structures under deleterious conditions such as freezing and thawing, exposure to de-icing salts, sulfates, alkali silica reactivity. This is where this type of research that is multidisciplinary will be going on.
And the room over here will be filled with chambers that can then cycle quickly between freeze and thaw and expose the concrete and other materials to marine environments, salt water, and look at the corrosion impacts that that's going to have and the salt intrusion into the materials. So this is going to really be a unique facility, and we're focusing on a lot of work with extreme environments and also hazard mitigation that's really going to allow us to do research that no other place in the Midwest is going to be able to do. So we're wrapping up our tour today. Thanks for joining us as we walk through the Clayco Advanced Construction and Material Laboratory, the expansion of the Butler Carlton Civil Engineering Hall, and we're thrilled with the opportunity this is going to give us. This is going to give us the possibilities to do research and to train the engineers for the next generation that are going to go out and change the world. We've been building engineers here that built our world for a long time. We're going to keep doing that. We're just looking at staying advanced ahead of the game and changing the world for the betterment of everybody around us. So thanks again for joining us, and I look forward to having you here live and in person sometime soon so we can walk through the facility, maybe after it's painted and it's done. Thank you very much. Take care.
Well, thank you for joining us for this nice tour. We're very excited to have you here on campus when this facility is completed. This has been really a dream come true. We started working on this back in August 2011. And then a lot of people have participated in this vision, starting with the leadership of the university, both the UM system, Missouri S&T, the OSP, as well as the leadership of our department, Civil Engineering. Many people have contributed to this, from staff of the CIS to a physical facility who have helped the design process and the construction management, as well as the development, and especially the donors without whom this project could not have been realized. Thank you very much.